Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, this is the video to cover section 2.4 inequalities. Okay, the learning outcome. Okay, learning outcome from this section, you should know how to solve quadratic inequalities by using graphical and analytical methods. Okay, second is to solve rational inequalities. Okay, a fraction. And then third is to solve inequalities that involve modulus of a function. Okay, so firstly we look at quadratic inequalities. Okay, from your reference book, okay, 2.4.1.2, there's a theorem. Okay, the theorem states that when AB is bigger than 0, so AB is bigger than 0, so means AB is a positive number, right? So a positive number must come from a multiplication of a positive with a positive, or a negative number and a negative number. So that's why the theorem stated that AB is bigger than 0 if and only if A is a positive and B is also a positive. Okay, sorry, I should not use this. Okay, this looks better. A bigger than 0 and B is bigger than 0. Okay, or A and B could be a positive number if and only if A is a negative and B is also a negative number. Yes, a multiplication of a negative number with a negative number will give us a positive number. Alright. Okay, then second, the theorem also states that AB is less than 0. AB is less than 0 if and only if A is bigger than 0 and B is less than 0. Why? Because the theorem states that AB is a negative one. So AB is a negative number, so that means it must come from a multiplication of a positive number and a negative number. Or it could also be A is the one that is negative and B is the one that is positive. Okay, you have to know this theorem, you have to understand it, you have to memorize it. Okay, not memorize but read, you have to remember it, because later on we will be using this theorem to solve our quadratic inequalities. Okay, so next let's look at method to solve quadratic inequalities by using graphical method. Okay, before we go to examples, I have to explain this to you. Okay, the general form of a quadratic equation, that is ax squared plus bx plus c. Okay, so ax squared plus bx plus c is the general form of quadratic equation, and we make it a quadratic inequalities by putting bigger than 0. Okay, let's make this a number 1. Okay, number 1, we consider it as the main, okay, the main form, the prime form of to solve these quadratic inequalities by graphical method. Okay, when you have a positive quadratic inequalities, ax squared plus bx plus c is positive, and the symbol of the inequality is bigger than, is a positive and bigger. So the shape of your quadratic will be like this, and the region of x, okay, the region of x of your answer must be the one that is outside of the curve, because the quadratic inequalities is positive and the symbol of the inequality is also bigger than 0. Okay, so what happens if we make it a negative quadratic inequalities? Okay, we label it as number 2, negative ax squared plus bx plus c, that is still bigger than 0. Okay, when we put a negative sign, the region will go to the inside. Okay, when we change the equation, we put a negative sign, the shaded region will go to the inside of the curve. Okay, so now we back to number 1. Number 1 is a positive quadratic, and the inequality is also bigger than. Okay, now let's make another number 3. Another positive quadratic plus bx plus c, but now we change the sign. The sign will be less than 0. Okay, when the sign becomes less than 0, okay, initially number 1 is the initial situation, initial state. Okay, the region is outside. When we change the sign, becomes a less than, then the shaded region will cover the inside of the curve. Okay, these 2 points are the roots of the quadratic. Okay, then our example for number 4, we make it a negative quadratic inequality, but with a symbol of less than 0. So it is a negative, and the symbol is also a less than 0. So then the region will be the outside of the curve. So there is only 2 states. Okay, the first state is where the region is outside. When you change, you place a negative sign, so the region will go to the inside. When you flip the direction of the inequality symbol, the region will also go to inside. When you have both negative and the symbol of inequality is less than, the region will go to the outside. Okay, so now let's look at an example. Our first example, example A. We solve these quadratic inequalities by using graphical method. Okay, we have x squared minus x minus 6 is less than 0. Okay, we firstly identify, okay, this is a positive quadratic, and the symbol is less than. Okay, the symbol of the inequality is less than 0. So first, what we need to do, we have to identify the roots of the quadratic. So the roots of the quadratic will be at -2 and 3. Okay, you can factorize the equation. So then the shaded region will be at the inside of the curve. So that means it covers from -2 until 3. So our answer from here is that -2 until 3. Okay, you have to read the equation, whether it's positive or negative, whether the symbol is bigger than or less than. Okay, next, our example B. That is 2x squared minus 5x minus 3. 2x squared minus 5x minus 3 is bigger than or equal to 0. Okay, firstly, we factorize the inequalities. So that means we have 2x plus 1 and we have x plus 3. Okay, we have x plus 3 that is bigger than 0. Okay, first, the quadratic is positive and the symbol of the inequality is bigger than. So from what I have told you, the region should be at the outside of the curve. Oh, sorry, actually the factorization is x minus 3. Okay, so your region for the answer will be from -infinity until -1/2. From -infinity until -1/2 union 3 until positive infinity. Okay, one thing here, you have to focus at the symbol of the inequality. So the inequality mentioned that bigger than and equal. So that's mean the symbol of the bracket here, the type of bracket you need to be changed. You have to use a square bracket because it is bigger than and equal. Okay, our next example, our last example to solve quadratic inequalities by graphical method. C. So we have negative 3x squared plus 26x less than 16. Okay, so from here we bring the 16 to the left. X squared plus 26x minus 16 less than 0. Okay, then what we do, we factorize out the negative symbol. Okay, 3x squared minus 26x plus 16, that is less than 0. Okay, if you want to use your calculator to factorize this quadratic equation, so make sure the a becomes a positive first. Okay, for example this, the a is a negative 3. So you should never find the roots of a quadratic by keying a negative a into your calculator, because you will have it will give you a different meaning. Okay, if you key in negative 3x squared plus 26x minus 16, then it will show you the answer will be 3x minus 2 and 8x minus 8. Then you will do it like this, less than 0. So you will be missing a negative sign. You will be missing this negative sign. So that's why before you key in a quadratic inequalities, a quadratic equation into the calculator, make sure you factorize out, make it the a is a positive number. So you key in 3x squared minus 26x plus 16, and then you just put a negative sign in front. Okay, so from that we know that this is a positive quadratic equation. So sorry, it's a negative quadratic equation, and the symbol is also a less than. So we have 2 over 3 and we have 8 right here. So the shaded region will be at the outside of the graph. So your answer negative infinity until 2 over 3 union 8 until positive infinity. Okay. Okay, now let's move on to solve quadratic inequalities by using analytical method. Okay. So there are 3 methods to solve quadratic inequalities by analytical. So first method is to use table of signs. Okay, second we have a real number line. And third, we have a basic theorem. Okay, these 3 methods they appear differently. They use different method. Okay, so firstly, let me show you to solve quadratic inequalities by using table of signs for the same example that we have done for graphical method. Okay. We go for same example, that is x squared minus x minus 6 less than 0. Okay, the first method is to use table of sign. Okay, the table of sign, first we factorize. Okay, we factorize the quadratic inequalities. Then we have x plus 2, x minus 3, that is less than 0. Okay, so we stop there. Stop right there. So that is the factorization I've done. So what we do next is we take x plus 2 equal to 0, and we take the x minus 3, we make it equal to 0. So we should have x equal to negative 2, and we have x equal to 3. Okay. Okay, what I want to show you next is I draw this line. Okay, this line is not required for you to draw in order to do table of sign. but I just want to show you what is meant by what I will do next. Okay, so we have the roots at -2 and at x equal to 3. So means the line is now separated, divided into 3 regions. Okay, the first regions that covers from -infinity until -2. The second region, the first region, the second region is from -2 until 3. Okay, then the third region is from 3 until positive infinity. Okay, that line is not necessary for you to draw in order to use table of sign, but what is necessary for you is to draw this table. That's why the name is called as the table of sign. So now we have 3 regions divided by the roots of the equation. So we have 1, 2 and 3. So we draw the table like this. Okay, for the second column, we place the equation for the first region where the x is less than -2. Okay, for the third column, we draw the second region that is from -2 less than x less than 3, and the fourth column we write here is x bigger than 3. That represents the third region. Okay, then what we do next for the second row is the test value. So what is meant by the test value is we choose any value that is located in the region. For example, for the first region, we can take any value that is less than -2. So let's just take -3. Okay. Okay. For the second region is any value that is in between -2 and 3. For easy things to do, okay, it's easier to just choose 0 because 0 is situated in between -2 and 3. And for region number 3, any number that is bigger than 3, okay, let's just choose 5. Okay. Okay, then under the test value, we put our first root, that is x plus 2. Then we put our second root, x minus 3. Okay, now we have our test value and we have our root. Okay, now let's substitute -3 into the roots. Okay, so that's mean for the first root, that is x plus 2. So now we will have -3 plus 2. So -3 plus 2 will give you an answer for -1. So the table here, you just draw a negative sign. You just write a negative sign there because it is a -1. It's a negative number. Okay, then for the second root, you substitute -3 minus 3. So it becomes -3 minus 3. So it becomes -6. Also a negative sign. Okay, just draw the negative sign. Okay, now let's move on the third column, which is the second region. Okay, the second region, we have our test value that is 0. We substitute 0 into the first root, so we have 0 plus 2, we have equal to 2. So 2 is a positive. So 0 minus 3, we have -3. So it is a negative. Then third region, we have x is bigger than 3. So we have 5 plus 2 equal to 7. So 7 is a positive. And then we have 5 minus 3 equal to 2. Then it is also a positive. You don't need to draw, you don't need to write down the equation, right? Like the 5 plus 2 equal to 7. You could just write down the symbol, whether it is positive or negative, when you substitute the test value into the factor. Okay, then we know that the two factors are actually multiplied together. Okay, the two factors are actually multiplied. That is written as x plus 2 and x minus 3. So that's mean for the first region, our answer is a negative, then also a negative. So that's mean a negative multiply a negative, it will produce a positive sign. So then a positive multiply with negative, it will produce a negative sign. Then we have a positive multiply with positive, we give you a positive sign. Alright. Okay, so now we have done for the table. So we have a positive, negative, and positive. Okay, now we back to our quadratic inequalities, equation of our quadratic inequalities, which is here. Okay, we can see that the symbol of the inequalities is less than 0. Symbol of inequality is less than 0. So that's mean the value is a negative. So that's mean we have to choose a negative region for our answer. So this is our answer, that is in between -2 until 3. If the region, the quadratic inequality symbol is bigger than 0, so then you choose a positive symbol. If it is less than 0, then you choose a negative symbol. Okay, never mind. We will do another example that we will try to solve that example also by using a table of sign later. But now I want to show you the second method, which is the real number line. Okay, we do it on the same question so that you will see the differences. So now we look at x squared minus x minus 6, that is less than 0. So as usual, we factorize it first. X plus x minus 3 less than 0. Okay, so in order for you to perform a real number line method, okay, you done the factorization. So now begin the part where you apply the real number line steps. Okay, you take the first factor, x plus 2, just make it bigger than 0. Tak kisahlah, less than or bigger than, just make it bigger than 0. Then you take x minus 3 and also make it bigger than 0. So now we have x bigger than -2, x is bigger than 3. So for real number line, you have to draw a line. So -2 and 3. For table of sign, you have to draw a table. For real number line, you have to draw a line. Okay, so written here x is bigger than -2. Then you make an arrow that comes from -2 to the right, because x is bigger than -2, and the region where the arrows go is the positive region, and the region where the arrow didn't go is the negative region. Okay, then for x is bigger than 3, so mean x bigger than 3, it go to the right. So the region where the arrow goes is a positive region. The other region will become negative. Okay, next. So now we have a negative, negative. So negative multiply negative, it become positive. Positive and negative become negative. Positive and positive become positive. So we back to our inequalities. We want an answer that is less than 0. So we choose a negative sign as our answer. So our answer is -2 until 3. So just the same answer where we done table of sign. Okay, now we go to the third method, that is called as the basic concept. Okay, this is the basic concept. The same equation, x squared minus x minus 6 less than 0. We factorize x plus 2, x minus 3 less than 0. Okay, for this basic concept, you have to flashback about the theorem that I have told you at the early of this video. Okay, so the theorem state that the second phrase, AB is less than 0 if and only if a is bigger than 0, or and b is less than 0, or a is less than 0 and b is bigger than 0. Okay, so for this one we have to do both of it. We have to do a bigger than 0, we have to do a less than 0. Okay, so means from here we separate it into two parts. Okay, the first part is where we have x plus 2 bigger than 0 and x minus 3 less than 0. And then we have a second part where the x plus 2 is less than 0 and x minus 3 is bigger than 0. Okay, don't forget the things, the or in between those two, a bigger than 0 and a less than 0. So means the relationship between the first part and the second part is or. Okay, we will see later what we will do to our answer. Okay, so now x is bigger than negative 2 and x is less than 3. So that's mean we have a negative 2 and we have 3 right here. So x is bigger than 2. So we go to the right. So x is bigger than 2. So where x is less than 3, then it go to the left. The symbol of n in between this x bigger than negative 2 and x is less than 3 means the region must be the region where it intersect with each other. So the region that is intersect is in between negative 2 and 3. Okay, so next we will look at x, the second part. X is less than negative 2 and x is bigger than 3. So we have 2 and we have 3. We have negative 2 and 3. So x is less than negative 2. X is less than negative 2 and x is bigger than 3. So since there are no region that intersect with each other, so there will be no answer that comes from our second part. So as I mentioned before, the relationship between 1 and 2 is OR. So that means we have to draw a third line, okay, a third line that gathers all of the answers given from our first part and the second part. So first we label all of the points. We have negative 2 and we have 3. So from the first part, since it is OR, so we have to take all of the answers given from part 1 and from part 2. So from part 1, it tells us the answer will be in between negative 2 and 3. So since from part 2 there are no region that intercepts, so there will be no answers given from our part 2. Okay, so from here we can conclude that our answer will be from negative 2 until 3. Okay, just as the same answers that was given by table of signs and real number line. Okay, now let's do the second example from the graphical method we have did. Okay, that is for question B, 2x square minus 5x minus 3 bigger than or equal to 0. Okay, firstly, as usual, we have to factorize this x minus 3 and 2x plus 1. That is bigger than or equal to 0. Okay, first, to solve this by analytical method, we solve it by using table of sign. Okay, we have table of sign. Okay, so for table of signs, we take the factor x minus 3 equal to 0, x equal to 3, and 2x plus 1 equal to 0. We have x equal to negative 1 over 2. Okay, so that is the point. So then next we draw the table. Okay, then it will be okay. The table, the first region is from where x is less than negative 1 over 2. Okay, then in between negative 1 over 2 and 3, then the region that where x is bigger than 3. Okay. So now let's choose our test value. Okay, our test value where x is less than negative 1 over 2, we take negative 2. So in between negative 1 over 2 and 3, we take 0, bigger than 3, we just take 5. Okay, so then our first factor there is x minus 3, and then 2x plus 1. Okay, so we substitute our test value into each of the factor and see whether it is a positive number or a negative number. So this one we will have a negative. So then for 2x plus 1 we will also have a negative, a positive, then also a positive. Okay, so for the last part we have the multiplication of those two symbols, so x minus 3 and 2x plus 1. So it gives a positive, negative, then a positive. Okay, so we have done for the part of the table. So now we back to our inequalities. So we can see that the symbol is bigger than or equal to 0. So means we want a positive region for our answer. So our answer will be from negative infinity until negative 1 over 2. Sorry, negative 1 over 2 must be closed with a square bracket because the inequality sign is bigger than and equal. And union 3 until positive infinity. So that is our answer by using table of sign. Okay, now let's move to solve the same question by using a real number line. Okay, for real number line, we have the factor x minus 3. We have 2x plus 1, bigger than or equal to 0. Now, from the table of sign, we take the factor and just make it equal to 0. For real number line, we take the factor and just make it bigger than 0. 2x plus 1 bigger than 0. So we have x bigger than 3 and x is bigger than negative 1 over 2. Then we draw a line, negative 1 over 2, and we have 3. Okay, so we have x is bigger than 3. So that means our arrow will go to region that is bigger than 3. And where the arrow goes, there goes the positive sign. Okay, then x is bigger than negative 1 over 2. So means the arrow will go to the region that is bigger than negative 1 over 2. So where the arrow goes, there goes the positive sign. Where the arrow doesn't go, there goes the negative sign. Okay, then the multiplication of negative and negative is positive, negative and a positive. So we back to our inequalities from our equation. Equation 1's region that is bigger than or equal to 0. So that means our answer will be these two positive region. So answer same negative infinity until negative 1 over 2. Don't forget the square bracket, union square bracket 3 until positive infinity. Okay, then lastly we solve it by using basic concept. Okay, so for basic concept, we take the factor, the factorization of the equation 2x plus 1 bigger than or equal to 0. Okay, you have to remember back the theorem. The theorem said A be bigger than 0, so there will be two outcomes, A bigger than 0 and B bigger than 0, or A less than 0 and B less than 0. So means we separate it into two parts. So we make this as the first part and this is the second part. Okay, for the first part we write it here. A is bigger than 0, so mean we take x minus 3 bigger than 0. 2x plus 1 is bigger than 0. So x is bigger than is bigger than positive 3. Okay, then we have x is bigger than negative 1 over 2. So we draw a line, negative 1 over 2, and we have 3. So x go to the region that is bigger than 3. And we have to draw inequality with a equal sign. Okay, and then x go to the region that is bigger than negative 1 over 2. Okay, so the relationship in between x bigger than 3 and x is bigger than negative 1 over 2, we refer from here. Okay, we refer from here. The theorem said the relationship is n. So means n with this symbol. So means it wants a region that intercepts. The region that intercepts is this region. Okay, so we have done for the first part. Okay, so then we do for the second part. Okay, we look back at the theorem. The theorem said the relationship between the second part and the first part is OR. So there must be OR in between the one and the second. Okay, we look at that later on. Okay, then we have x minus 3 less than 0. Then we have 2x plus 1 less than or equal to 0. Okay, so the relationship is n. N from here. So with the symbol of n. So x less than or equal to 3. So x less than or equal to negative 1 over 2. So we draw a line, negative 1 over 2, 3. So x is less than 3. So x is less than negative 1 over 2. So the relationship is n. So it wants a region that intercepts. Okay. So now we combine it together with the relationship of OR. Okay, we bring OR down here. OR. So means we combine. We have negative 2, 1 over 2, and we have 3. Okay, so we have a region shaded from the first part that covers from first part. Okay, then the region from the second part is less than negative 1 over 2. They come from the second part. So our final answer will be from negative infinity until negative 1 over 2, a square bracket, union 3 until positive infinity. Okay, so that is how you solve a quadratic inequalities by analytical method. That we have 3 methods: table of sign, real number line, and finally we have a basic concept. Okay, make sure you know how to differentiate each other. Don't mix one and another. Okay, refer to the question, whether the question want you to use which methods, table of sign, or real number, or basic concept. Okay, you have to know all 3 methods. Okay, even though all 3 methods also give you the same answer, but you have to know, you have to master all of 3 methods, because your marks will depends on the question given. Yes,